welcome to the 9th Arduino tutorial in which we're going to be talking about servos, what the benefits are, what you can do with them, what usually comes in a standard servo package, how you can program them, what's a good way to wire them, etc. So without any further delay, let's get started. You have a lot of options when it comes to servos. So when you go for the very inexpensive servos, what you have to watch out for is the plastic gearing inside. So those are typically gonna wear off much quicker than the metal geared ones. So as you can see, I have the MG 995 that I'm going to be showcasing in this video. Generally, your kit is going to come with the servo itself. You're going to get a screw which will be used to hold in one of these knobs, and generally the kit comes with one or more of these rotating heads, if you want to call them that. So what you want to do is, first of all, pop them on your servo, and you can obviously change it afterwards if you don't like its 0 to 180 degree sweep, because you can obviously mechanically offset it to whatever you wish. And you're going to set in your screw like so, and you would be ready to get started with the programming of your servo. So what you also need to know is the general coloring of your wires. So the red one is, I want to say, always the +5 or plus whatever voltage you're using. Brown is generally the ground, and orange is your signal bus. So this is going to dictate how you're going to hook it up to the Arduino. And just quickly overviewing why you would need a servo for. So the servo itself has a control system which would dictate the position of the arm. What that means for you essentially is that it's going to be a precise position versus a DC motor, which is just going to rotate, and unless you place an encoder and do some kind of processing on that, you're not gonna really know what the position is. So you would use these if you have any kind of an arm, if you want to have linear motion, if you want to implement a sort of a piston, if you want to call it that. So anything that requires you to have a movement which would be predetermined, essentially. You can use it on RC planes, RC cars. You can use it on a robot to essentially pivot a camera, which would be, or a sensor, which would use to capture the obstacles in front of the robot, and many other applications where you essentially need a precision type of a rotation. So let's take a look at how we hook it up and then program this device. So in order to hook up the servo, it is necessary for me to use male-to-male wires, since both of the servo and the Arduino have female plugs. So the signal bus generally connects to a PWM pin. Unless you want to simulate that in the software, you're going to have to use essentially pin 11, 10, 9, 6, 5, or 3. So in my case, I'm going to put it into 9. I'm going to also plug in the ground and the power buses onto the Arduino. And that's your basic setup. This doesn't do any noise cancellation whatsoever. This doesn't really turn the servo on or off necessarily. Just keep sending it a signal, and it's going to maintain the control loop of the servo on. So let's take a look at the basic controls that we can do with the servo. So Arduino natively contains a servo.h library, which you will include in your project. You'll create a servo element called servo1 in my case. In the setup, you can set up the pin on which your servo is plugged in. In my case, it's pin 9. And I'm going to write a 180 degrees position to my servo, which is going to put it to one of the limits. So you can write 180 or 0. And my loop is currently empty. So let's take a look at what the servo does in this case. Let's verify the program, upload it to the servo. Let's take a look. So let's take a look at what the servo does as soon as I upload the program we just created. So I press upload. and as you can see, it's at its 180 degrees position. So a few things you're going to notice. First of all, this knob is slightly offset. As you can see, it's not perpendicular to the servo, or if you wish it to be parallel to the servo. So what you have to do is, as I mentioned before, this is just something you have to live with because that's a mechanical positioning. So as soon as you know that your servo is set in your 180 position, what you want to do is take this knob and position it as best you can into the position you desire. So that's going to be done like so. I'm going to just put this back in really quick. So now what this tells me is that when I write 180 in the software, the servo is going to stay in this position. Another thing you're going to notice, or maybe not that well on camera, but the servo, it's currently jittering every so slightly. So I can hold it in my hand and very well feel a vibration, and sometimes it makes a light sound. So what that is the control system inside the servo. So it's constantly polling the position versus what position you sent it, and it's trying to readjust itself. So if you were to force your servo, or you have something that's kind of disbalancing the servo, it's trying to get back into its original position. So what that creates is that light jittering. So there's a lot of solutions on the web which provide troubleshooting guides for how to eliminate that. You can plug in capacitor circuits, you can plug in inductive circuits. Personally, I think the best way would be to just cut off the power of your servo when you're not using it. So you can do that with a simple transistor, and I'm going to discuss that circuit in a later video as well. But let's get back into the programming and implement a full sweep of the servo to actually see it go from 180 to 0 and
okay, so I've modified my program ever so slightly. As you can see, I've created an integer with the position, which is going to be storing the current position that I'm sending to the servo. In my loop, I have 2 for loops, one of which sweeps the servo from position 0 to position 180 in 1 increments, and the other one goes down from 180 all the way to 1. So within those 4 loops, I write the position, and I have a delay of 10 milliseconds simply to wait for this servo's mechanical motion to actually catch on to the position. So very straightforward. We're going from 0 to 180, and then from 180 back to the original position, and it's going to repeat this motion over and over again. So let's verify the sketch, upload it, and take a look.
So as you can see, the servo is currently sweeping the 0 to 180 degrees positions in a very little increments through this software. And what you want to notice is that the knob is always parallel to the servo in the 2 extreme positions of being 0 and 180 degrees, and this was something that I wanted to achieve through the repositioning of the knob through the mechanical screw. What you want to notice is that it's extremely simple to get started with a servo. You don't really need much. It's a very basic connection. Arduino provides you with the library, so you should be all set and ready to go if you want to use this in some of your projects. So let me know if you have any comments, suggestions, or if you have any questions related to the servo. As I mentioned before, I would like to research a bit more about some of the jittering problems that people have, and show you some of my own implemented solutions. So stay tuned, subscribe, and once again, thank you for watching.